Bismillah ar-Rahman ar-Rahim. We'll continue. We did these 4 cases for the Sanat asymptote. Now we'll go more with more graphs. As you notice, I mean, the same idea, but now the function is different. We have different functions. So now this is my function. So first I need to find the domain. Is there a restriction in the domain? Yeah. I want 1 plus e minus x not equal to 0. So when this is equal to 0, so I have e minus x equal minus 1, which is impossible to be 0. So it means the domain or real numbers. Domain R. Okay, but this is cannot be equal to 0. Because e minus x is always positive. Okay, now intercepts. Y-intercept, which is easy one. I would x equal 0. I'm getting y equal 1/2. So I have the point 0.5. Okay. X-intercept, there is no x-intercept. This cannot be equal to 0. No x-intercept. Symmetry, no symmetry. Asymptotes. Okay. I need to notice one thing. Now, is there a vertical asymptote? Would that go to infinity? The specific value? No way. So it will go to infinity. This is the denominator goes to 0, which is impossible to go to 0. So now check the limit. As this goes to infinity, this, I'm getting what? E minus infinity is 0, I'm getting 1. So I have y equal 1 is the horizontal asymptote. Okay. What else? I also want to check the limit as it goes to minus infinity of this. So I'm getting what? 1/1 plus infinity. So it will be 1/infinity. So I'm getting 0. So I have y equal 0 is also horizontal asymptote. As it goes to infinity, okay. Now, what else? As it goes to infinity, I'm getting 1. Is it? As it goes to infinity, it will be 1/1 plus 0. There's the minus infinity, it will be 1/1 plus infinity, at 1/infinity, which is 0. Okay, clear. Now, I'll check. What is it? What else? What is the remaining? Symmetry, not symmetry, nothing. Okay, so check f prime. F prime will be what? This is, I can rewrite it, make it easy, to the power -1. So that will be minus 1 plus e minus x to the power -2 times minus e minus x. So it will be e minus x over 1 square. This cannot be equal to 0. This is always positive. Okay, so f is increasing all the way. F is increasing in its domain. In its domain, which is R. F double prime. Yeah, I'm getting some values. So let me do the calculation. That will be minus e minus x times this minus e minus x times 2y plus e minus x minus e minus x all over this to the power 4. I'm getting what? Minus, oops. I'm getting minus e minus x, 1 plus e minus x as a common factor. And the remaining is what? I have here 1 plus e minus x. This is I'm taking. This is I'm taking. Minus 2e minus x over this, which is what? As usual. So I have 1 minus e minus x with a minus sign over e minus x, 1 plus e minus x cubed. Okay. If the y equals 0, I'm getting this is equal to 0. So I'm getting x equals 0. I will make it in 0 before and after. 0, take a negative value. That will be negative, positive. That will be positive. And after that, it will be negative. Okay, now let me grab the function. Let me grab the function. I have a 0.5. I have a asymptote here. Asymptote here, also the x-axis. By the way, this asymptote will be, this one will not be crossed for sure. No, this cannot be equal to 0, all of this. But let me check with 1. Will that be possible? And y equal 1. So I have 1. Which is impossible. E minus 6 equal to 0, which is impossible. So also this will not be crossed. Okay. Now, if you take a value, negative value, so the denominator will be bigger. So you have a small than 1. Then it will be, if take, for example, minus 1, I'm getting what? 1 over f of minus 1. It will be 1 over 1 plus e, which is smaller than 1, smaller than half also. This is half. Okay. And it is what? The function is increasing all the way. And it's concave up, this concave down. So it will increase. This is concave up. Then after that, it will concave down. This is one. Yeah, as x goes to infinity, it goes to around 1. So this is the function. This is the graph of the function. Okay. Another function. 2x 5 over 3 minus 5x to the more 4 over 3. Okay. Let us do the same thing. Domain or in numbers. Okay, this is cubic root, so everything is defined. Intercepts. Y-intercept, x equals 0. I'm getting y equals 0. X-intercept, y equals 0. So I'm getting what? 2x to the power 5 over 3 minus 5x to the power 4 over 3. And that will be what? That will give you x to the power 4 over 3 times what? 2x is 1 over 3 minus 5. Okay, make it equal to 0. So I have x equals 0. And x equal what? 2. And 2 cube root of x equal 5. So cube root of x equal 5 over 2. So x 125 over 4. Some number like this. Okay. This is the intercept. So I have 0, 0. 0. Okay, what else? Domain, intercept, symmetry, no symmetry, asymptotes, no asymptotes. The function is defined. We have no problems. Okay, so we'll deal with the f prime. What will be f prime? F prime will be 10 over 3 x to the power 2 over 3 minus 20 over 3 x to the power over 3 minus 1 minus 2 over 3 x to the power 1 over 3, which is 10 over 3 x to the power 1 over 3, a common factor. The remaining is what? Is x to the power 1 over 3 minus 2. Okay. Yeah. So f prime equals 0. I'm getting x equals 0 or x equals 8. Yeah. Or x equals 8. So it will do something like this. I have the 0. I have the 8. So before 0, take a negative. That will be negative times negative. That is positive. Take 1. That's positive. Negative. That will be positive. So it's increasing, decreasing, increasing. So I have local max here and local min here. Okay. Now, if double prime, from here I get it, that will be 20 over 9 x to the power minus 1 over 3 minus 20 over 9 x to the power minus 2 over 3. If double prime equals 0, which is what? 20 over 9 x to the power minus 2 over 3 times x to the power 1 over 3 minus 1. So I have x equal, no, I have x equal 1. And also if double prime does not exist, implies x equals 0. So I need the 0 and the 1. I need the 0 and the 1. So this is, you can write it, 20 have 0, 1. Okay. Where before the 0, take any negative value, I'm getting a negative. After the 0, then 0 and 1, take, that will be negative over positive, that will be negative still, that will be positive. So it's concave down, concave down, concave up. Okay. So if you want to put it in one line, it is increasing, then it's decreasing, decreasing, increasing. It's concave down, it's concave down, concave up, concave up. So the graph of the function would be something like this. I have 0, 0. This for sure is one of the points. And I have 125 over 4, which is something here, something big. Let me put it here. 125 over 4. Okay. And I have the 8. What is f at 8? F at 8 will be 2. Cubic root of 8 is 2. 2 to the power 5 minus 5, 2 to the power 4. That will be what? 64. That's 64. 2 to the power 4 is 16. Is 2. Yeah, 16 times 5 is minus 80. 16 times 5 is what? Minus 80. That is minus 16. Yeah, something like this. Okay. So it's a negative value here. With 8, I'm getting minus 16. Okay. Now what will happen? For the 0, the function is increasing and concave down. So it will do something like this. Okay. So for take a value with minus 1. F of minus 1 will be minus 2, minus 5, which is minus 7. So it will be something like this. Okay. Now, between 0 and 1 is decreasing and concave down. Decreasing and concave down. That will do something like this. Until 1, f of 1 is what? F of 1 will be 2 minus 5, which is minus 3. It will be something like that here, minus 3. That one. It will be concave down until 1. Then it will be concave up, still decreasing. Then it will concave up. And then it will concave up and pass like that. So no absolute maximum and no absolute minimum. Yeah, by the way, this is local maximum, yeah. And the range from minus infinity up to infinity. Okay. Taking all the value, something like that, yeah. Okay. I want to analyze just the graph of this function. Okay. Let us see what will happen for this function. Domain or real numbers. Are intercepts. Yeah. X-intercept, you can check easily. Y-intercept, I mean. Make X equals 0. So I'm getting what? Y equals 0. It's all the other way. X-intercept will make Y equal 0. So I'm getting X equal what? I'm getting X cubed minus 12x squared plus 48x minus 64 equal to 0. Yeah. When this is equal to 0. Yeah, you need to solve that somehow to find when it is 0, which I don't think it will be an easy things to do, but I can get the values. What is the values? So this is from the book, so I'm trying to get the value. It's 4. How to get it? It's not an easy task to do. Yeah, I know. It's not an easy thing, but they found out in f of x is x times x minus 4 cubed. I don't think there is a way to do it. Unless you use calculator, you need to put the 4, you need to put the 1, by the rational zero theorem, you have these, the factors of these, but it's not an easy task. So I have intercepts will be x equals 0, will be 0, 0, 4, and 0. Okay. Assume I have the function like this, so that will make it easy, make it easier. Okay. Now, for sure, no symmetry, asymptotes, no asymptotes. Then we'll go to f prime. So this is the function, خلاص, things that will be easy. So that will be x minus 4 cubed times 3x plus 3x x minus 4 square, which is x minus 4 square times what? X minus 4 plus 3x. Am I right? Yeah. Yes. So I have x minus 4 square times this 4x minus 4, so 4x minus 1. That implies f prime equal to 0. So I have x equal 1 or x equal 4. So I'll put 1 and 4. It will be what? 1 and 4. Before one take a value, this is my function. Take negative, take 0. It will be 4, positive, negative, that will be negative. 2, 1, and 4, take 3, that will be positive. Then that is always positive, that will be positive. Between 4 and infinity, that will be positive still. That will be also positive. So it's decreasing, increasing, increasing. So you have local minimum just here. Okay, if double prime, we'll do it from here. I think it will be very easy to do. It will be what? 8. It will be 8 x minus 4 times x minus 1 plus 4x minus 4 square. In other words, this is x minus 4, 8x minus 8. Eight x minus 8 plus 4x minus 16. Okay. So it's x minus 4. Here we have what? 12x minus 24. In other words, 12. Oh, there isn't. Yeah. In other words, that will be 12 x minus 4 times x minus 2. So I'll put 2 and 4. That will be positive, negative, positive. So it's concave up, concave down, concave up. Let me put it in one graph. So I have 1, 2, and then 4. Before 1, that will be decreasing. You'd have increasing all the way. This is concave down, concave up, concave up. This one concave down, and this is concave up. Okay. So now I want to graph the function. That will be my function. I have 0, 0. And I have 4, 0. I think I need some space here. 4 and 0. Let me take some space. Put them on here. Okay. Now, f of 1 is what? If this is f of 1 will be a very small number. Yeah, f of 1 from here, f at 1, 1 minus 4. 1 minus 4 is minus 3 cubed, minus 27. It's minus 27, some value like minus 27 of under 1. So this is 0. So this is 1. The value is minus 27. Also, 2 is important. F of 2 will be 2 times minus 8, so it's minus 16. 2 will be somewhere here. Still negative, but it will be somewhere here, minus 16. Okay, something like that. Okay, so less than 1, it's concave up and going down. Concave up, going down, less than 1. For the values, less than 1. Take 0. 0, I'm getting 0. Okay. Take a negative value, minus 1. It will be positive here. Minus 1 will give me what? 5 cubed, very big number. So it will be concave up and oops. It will be concave up and decreasing. Okay. Sorry. It will be do something like this. I want to make it concave up and decreasing. All the way. I want to concave up all the way. Oh. Then after that, it will be concave up, but increasing. So it will concave up, but increasing, not decreasing. And with 2 and 4, it's increasing and concave down. So it will do something like this. Then it will concave up and do something like this. Okay. That's sketch of the curve. Yeah. Okay. Now we'll do this one. Cosine x over 1 plus sine x. Okay. Now, what is the domain here? Domain, I need to be sure that 1 plus sine x, I need to avoid these things, not equal to 0. That means sine x not equal to minus 1. But I notice in f of x plus 2 pi is the same as f of x. So I will consider only 0 to 2 pi. I will deal only with 0 to 2 pi, and then just I will make a copy. Okay. So when sine x equal -1, that means x I need to avoid to be 3 pi over 2. Okay. Okay. So the domain R minus 3 pi over 2. I mean, it's not R. Now it is 0 to 2 pi. I'm dealing just with this. And then just I'll make a copy after that. Minus this value, where sine x equal -1. Okay. So I have a 3 pi over 2. I have something, a 3 pi over 2. Okay, intercepts. What intercept will make x equal 0. So I'm getting y equal what? 1. So I have 0 and 1. X intercept will make y equal 0. So I'm getting cosine x equal 0. So I have x equal pi over 2 and 3 pi over 2. But there's a problem with 3 pi over 2. So it's not there. So only pi over 2. Only pi over 2 and 0. Okay. Now, symmetric. No symmetry. Asymptotes. Yes, we have asymptotes here. Horizontal asymptotes, none. But vertical asymptote, I have with sine x equal -1. So I have x equal 3 pi over 2 is a vertical asymptote. As I said, I'm doing only one cycle. The rest is just a copy. Okay. F prime. F prime will be what? Will be minus sine x times 1 plus sine x minus cosine x times cosine x over 1 plus sine x all square. That give me what? Minus sine square minus cosine square, that is -1 over this. In other words, this is -1 over 1 plus sine x. Interesting. Okay. So I need to avoid, I need to consider only point of discontinuity. That cannot be 0. So I need to consider only the point of discontinuity. So I have 0, 2 pi, and I have 3 pi over 2 here. Okay. Now between 0 to 3 pi over 2, these things will be what? -1 over 1 plus sine x. Yeah, this is interesting. Zero to 3 pi over 2 takes 0, for example. I have sine 0. Yeah. It's 0, so I have negative. Since 3 pi over 2, I have third quadrant. Sine is negative, but cannot reach 1. So this is still negative. So it's decreasing. Okay. F double prime. F double prime, I need to differentiate this. So I have what? 0 times this, خلاص, minus 1 times cosine x over this square. make it equal to 0. So I have cosine x equals 0. So I need to consider x equal pi over 2. So I'll do 0 here, pi over 2. This is open. This is closed. This is 2 pi. Okay, this is closed. So between 0 and pi over 2, this one always run negative. So I have a cosine. I'm concerned about cosine. That will be positive. That will be negative. That will be positive. So this will be concave up, concave down. This is concave up. So make it in one graph. Actually, it's all the way negative, all the way decreasing. So no need to deal with that. Let me do one part from 0 to 2 pi, where I have asymptotes here. 3 pi over 2. I'm doing it only to 2 pi, huh? This is 2 pi, and this is 0. So now they have 0 and 1. This is 0 and 1. Okay. I have the vertical asymptote. This is they have pi over 2 and 0. So I have pi over 2 and 0. This is the point. And they have prime is decreasing all the way, but from 0 to pi over 2 is concave up. So it will do something like this. It will do something like this. Okay. Then it will be decreasing, but concave down. So something like this. After that, it's decreasing 3 pi over 2 and 2 pi, but concave up. So, and they have, yeah, it will do something like this. It will reach this. Then it will continue. It will do something like this. Yeah. It will repeat itself where this is 3 pi over 2, then this is one period. So the complete graph, I'll try to do this here. To do the complete graph. I have, this is 3 pi over 2. If I want, this is 2 pi. I know it's a 2 pi and 0. It's 1. It's not 0. A 2 pi. It's not. No, this is just the end of it. And it will be like this at 1. Here. No. F of 2 pi is 1. Huh? It will be 1. Yeah, it will be 1. So up to here. Okay. So to make it complete, I have also minus pi over 2. Then I have minus 5 pi over 2. And it will do this. It will go all the way until 1. Okay. Then it will go to here. Concave up all the way. Then it will concave down. Then it will concave up again. And continue. Where this is will be what? 3 pi over 2 plus 2 pi. It will be what? 7 pi over 2. Yeah, 7 pi over 2. It will be concave up. Then it will concave down like this. And continue doing it like this. Okay. Yeah, something like this. Okay. Now we'll go to a different function. We have arctan x all square. Let us what will happen with such function? Domain Fourier numbers, intercepts. Y-intercept on x equals 0. So I'm getting y equals 0. Okay. Okay. X equals 0. And tan 0. Tan inverse of 0 is 0. 0 squared is 0. So I have the point 0, 0. X-intercept will make y equal 0. So I'm getting that when tan inverse x equals 0, that means x equals 0. Tan inverse only at x equals, so the same thing. Okay. It's needed. We don't go to too many things, but I know that the limit as this goes to infinity of tan inverse of x square, that will be pi over 2. That will be limit as x goes to infinity of tan inverse of x square, and that will be pi over 2. That will be pi square over 4. Limit as this goes to minus infinity of this pi square over 4. Okay, now let me find f prime. Two tan inverse of x for 1 plus 1 over x square. So it's 2 tan inverse over 1 plus x square. Okay. When that f prime would be 0, implies x equals 0. That's the only things. So I have the 0. Before that, it's negative, then it's positive. So it's decreasing, then increasing. Okay. F double prime. Let me see how f double prime will be. It will be 2 times 1 over 1 plus x square is the derivative numerator times the denominator minus the numerator times derivative denominator is 2x over how to solve this 1 plus x square all square. So that will be 2 1 minus 2x tan inverse of x over 1 plus x square all square. Yeah, which is not easy to solve. To solve that, yeah, I don't think it's an easy equation to solve. Yeah, so you need to approximate it. If you approximate it, then x equal plus or minus 0.765, which is, yeah, not easy to do. This I get it from the book, so I'm getting the values from the book. So I need 2x tan inverse of x equal 1. This is approximation. It will be x equal plus or minus 0.765, something like this. Okay, we cannot do it without the calculator, which is plus or minus Let me double check. 0.765. Yeah. So it means they have, I need to check two values. I will put them. So we have minus 0.765 and plus 0.75. Yeah. You need a calculator to do that, but we can continue. With this minus, take a negative value, for example, -1. Yeah, this is always positive. So I'm concerned here. If you have -1, that will give you minus pi over 4. And this is minus. So it will be 1 minus pi over 2. Pi over 2 is more than 1, so that will be negative. But this is will be 0. At 0, I have what? This is 0, that will be positive. More than 1, that will be pi over 4, still minus pi over 2, which is negative. That will be concave down, concave up, then this concave down. Okay, now let me graph the function. Sketch the graph of the function. The only things is this, not an easy values to get, which is to do it through approximation. This is actually example in the book, but I want to do it just to see different ideas. I have this is 0, 0. I have asymptotes. This is pi square over 4. And this is minus pi square over 4. Okay. With these are asymptotes. Okay. Now, what will happen between minus infinity to 0, the function is decreasing, but it will be concave down until this value, minus 0.765. So it will do something like that, concave down until this value, then it will be concave up until this value. It will cross this. Okay, it's concave down until this value. Then it will concave up and also have the value here. Then it will be concave up also. Then it will concave down again. Let's concave down like this. It's going the other way. It's concave down until here. Then it will, no, it will be increasing. Wait a minute. It will be concave down until here. Then it will concave up. Yeah, here, still going down. Here it's increasing. So it will do something like this. It will concave up until this. The value will be here. Yeah, it will be positive actually. Okay, both are positive. And then it will go like this, concave down. Something like this. Okay, up. Then concave down. Okay. Consider this function. We want to graph this function. A different function, different examples. Yeah. Yeah, I'm going to graph it quickly, given that domain or real numbers, intercepts 0, 0, both x-intercept and y-intercept. Symmetric, yes, I have f of minus x equal minus f of x. So it's symmetric with respect to the origin. origin. Okay, what else? Asymptotes, no asymptotes. Oh, we have horizontal asymptotes. We have horizontal asymptotes, yes. Y equals 0. No x-intercept, no vertical asymptotes. Okay, we'll do f prime. If we do the calculations for f prime, you will get something like x minus 1, x plus 1 square. F double prime, just for completion, that will be 2x. Okay, here I have f prime equals 0. So I have x equal plus or minus 1. So I plug these numbers. I have minus 1 and 1. Before that, take minus 2. That will be negative, negative, negative. That will be negative, positive, negative. Here I have f double prime equals 0. So I have x equals 0 plus or minus square root of 3. So I plug these numbers. What you have? Before this number, minus 2, for example, be negative, positive. This is always positive. That will be negative, positive. That will be negative. That will be positive, negative, positive. You can check. So let me put them in 1, minus 1, minus square root of 3. Well, I can do the graph right away. So the graph of the function will be what? I have 0, 0. I have the asymptote, so the function either going this way or that way. The asymptote will be crossed. This one equals 0. Yes, implies x equals 0. So it will be crossed if x equals 0. I mean, the asymptote, if you think about the asymptote, this is the function. Will the asymptote will be crossed? Check y equals 0, and this, I have x over 1 plus. So I have x equals 0. So it will be crossed only at this point. So, you know, either the graph will go like this or will go like this. How to check? Check value. Take a negative value, so it will be here. So the graph will do something like this. So it is going, it's decreasing up to minus 1. What is f of minus 1? Easy to do. That will be minus half. So minus 1, that give me minus half somewhere. This is the point. So the function, and what is minus square root of 3? Yeah, let me put them in one side. I think it's better. Yeah, always this is what happens. So this is decreasing, decreasing. Then it's increasing, increasing. Then it's decreasing, decreasing. This is concave, down, concave, up, concave, up. Then it's concave, down, concave, down. Then it's concave, up. Okay. Okay. Also, minus square root of 3 is important. Minus square root of 3 is something like there. F of minus square root of 3 will be what? Minus square root of 3 over 4. Yeah. It means it will be a value here somewhere. Yeah, by the way, I have local minimum here, huh? Local min. And here I have local max. Okay. Minus square root of 3, minus square root of 3 over 4. And the upper one is minus 2 over 4. So minus 2 will be, yeah. So that will do something like this. Going down, concave down until here. Then it will do, it's concave down, then it will concave up. Here, concave up. Still decreasing. Then it will do what? Here, this is -1. Then it will increase, concave up, like this. It's symmetric about the origin, so the rest is just a copy. We'll do something like this, where I have 1, I care about 1, I care about square root of 3. That will be positive now. So it will do something like this. And it's concave between 0 and 1, it's concave down. Okay. And between 1 and 3, also it's concave down. Then for 3, it will concave up like this. Something like this. Okay. I think the idea is very clear. I'm not sure if we need to do more problems. Yeah. Let me try to do at least this problem where what is the domain? Fourier numbers, intercepts. I have x equals 0, 0 for both of them. Symmetry, no asymptotes. Asymptotes, as x goes to minus infinity, there is an asymptote. You know that the limit, as it goes to infinity, it will be infinity, but as it goes to minus infinity, I have x squared e to the power x. That gives me infinity times 0, which is if we check through L'Hopital's. So, but limit as it goes to infinity, this function will be infinity. This you need L'Hopital's rule, huh? I need section 5.6. Okay. Prove that limit. Now we'll do f prime. What is f prime? If we do the calculation, f prime will be something like this. 2 plus x. Which means I need to check -2 and 0. Okay. Before -2, take -3. That will be negative. That will be positive, negative, positive. So it's increasing, decreasing, increasing. That is local max. And this is local min. F double prime. Do the calculations, you'll get something like this. Ax 2 plus 4x plus x squared. So I need f double prime equals 0. I need to solve this equation, which has a solution. X will be what? -4 plus or minus square root b squared 16 minus 4ac, which is -8 over 2. And that give me what? -2 plus or minus square root of 2. Okay. -2 plus or minus square root of 2. So I need to put these values. -2 minus square root of 2 and -2 plus square root of 2. Take a value here, -4. Who cares? -4, you get to -16 plus 16 times 2, that will be positive. That will be, yeah, -4, it will be -16 plus 16 plus 2, that will be positive. Take a 0, still it's positive. Strange. No, there's something wrong. Yeah, I'm checking this. Okay. Take a value, for example, -5. Who cares? minus 5 will give me positive, صح? Minus 20. Zero give me 2. 0 also give me, will be positive. Yeah. Take a value. Take minus 10, for example. Say minus 40 plus 100. 2 plus 4x plus x squared. Is there a minus sign somewhere? No. How it comes? If I take any plus values, that for sure it will be plus. For sure this is positive. Take 0, should be negative. Why is doing this? I'm afraid there's a problem in the calculation. Maybe there's a problem in the calculation. This concave up 0. Or that's concave down, that's concave up. Well, I take a value like minus 2. Yeah. Okay. Minus 2 will give me negative. So that is negative, that is positive. Sorry for that. So it's concave down, concave up, this concave down. A value between these two, minus 2. So that will be concave up. Minus 4, it give me positive, so concave down. So it's concave up, then concave down. Sorry. Okay. Now I want to sketch the curve. Before minus 2, that will be minus 2 somewhere. Minus 2 minus square root of 3, it will be somewhere here. And this is minus 2. There's only the intercept is here. Okay. And this will be, yeah, 0. I need the 0. 0 for decreasing, increasing. So it will increased until minus 2. And it will be concave down, then concave up, concave increasing, concave up until here. Not that big. It will concave increase slowly here. Then it will concave down. 0 is where? This one is less than 0. 0 is here, okay. Then it will, yeah, what is this? This is concave up, this is concave down, this is concave up. So it will concave up until this, then it will concave down until somewhere here. Minus 2 over square root of 3 is somewhere here. Concave down until somewhere here. Then it will concave up again and will increase. Okay. So it's increasing until here. Let me just do it again. Or put these, no need, I think. Until minus 2, it's increasing and concave up. Oops. So it's increasing and concave up. Then it will decrease. No, it will still increasing. This is doing it slowly, huh? Then it will concave down, but increasing still until here. Then it's decreasing and concave down, huh? Still decreasing and concave down until here. then it will concave up and increase concave. Something like that. Okay. I think I'll do this. Yeah. Domain-oriented numbers. Intercepts. Y-intercept. X equals 0, so Y equals 0. Y equals 0, yes. X-intercepts. Y equals 0. I have X equals 0 or X equals 5. Okay. So I have 0, 0, 5, 0. Asymptotes, no asymptotes, no symmetry. We'll go to F prime. F prime will be something like this: 5x minus 2 over 3 cube root of x. So I have F prime equal 0, x equal 2, F prime does not exist, x equals 0. So I'll put 0, 2. Before 0, negative, 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 that will be positive, that will be negative, that will be positive. Increasing, decreasing, increasing. So I have local max here, a local min here. Okay. Something like that. Okay, f double prime will be 10 times x plus 1 over 9 cubic root of x all to the power 4. So I need to care about x equal minus 1 and x equal 0. Minus 1 and 0. Before minus 1, it's always positive. That will be negative, positive, positive. Okay. Now I need to check the asymptotes or the graph. That I have 0, 0 and 5, 0. 0. So now, yeah, if I put those in ones, I think always better to do this. Minus 1, 0, 2. That will be, it's increasing, increasing, then decreasing, then increasing. This one is concave down, then concave up, concave up, concave up. Something like that. Okay. Now let me check. Before minus 1, what will happen at minus 1? It will be f of minus 1, it's 6. So 6 or minus 6? That's minus 6, sorry. Minus 1. Give me a value here, minus 6. Where it will change concavity. It's increasing, but it was concave down. It was doing something like this. Then it will change to concave up, something like this. Okay. After that, it's decreasing and concave up, decreasing and concave up. Check f of 1. F of 1 will be what? Minus 4. So it's negative. F of 2, I think. I need f of 2. F of 2 will be what? Minus 3 cube root of 4. So it's a negative value. So it's concave up and decreasing until 2, which is the negative value here. Then it will concave up and increasing. Something like this. and increase. Yeah. Okay. Yeah. Let me do this one. Okay. Yeah. What is the domain? Orion numbers. Intercepts have 0, 0, and -2 and 0. Very clear. And what else? Asymptotes, no asymptotes, no symmetry. F prime. F prime will be 2x plus 1 over x to the power 2 over 3. So I need the minus half and 0. Minus half and 0. Before minus half, take -1. That will be negative. Minus half, there will be change. That will be positive. That will be positive. So it's decreasing, then increasing, increasing. Okay. But I have local minimum here. F double prime, if you do the calculations, you'll get something like this. 4x minus 1 over 3 cubic root of x to the power 5. So I'm concerned about 0 and 1. 0 and 1. And before 0, take a negative value. That will be positive. Then it's negative, then it's positive. If you combine them in 1, that's minus half, 0, 1. So I have what? Decreasing. Then it will be increasing all the way. That's concave up. That's concave up. Then it will be concave down, concave down. So I check f of minus half or f of 0. F of 0 is 0. F of 0, 0, known. F of 1 will be what? 2 times 3, it will be 6. F of 1 equals 6. F of minus half, it will be a positive value also, or a negative. Minus half, it will be what? Minus half, we have f of minus half, it will be positive, negative. That will be negative, so negative value. Okay. Yeah, because this is negative, but this is positive. Okay, so it will be negative. Yeah, just to be sure. So I have 0, 0, and I have -2, 0. Okay, and it's before I have minus half, something here, and it'll give me a negative value here. Is it minus half? At 1, it will give me a positive value here, some 0, 6. Okay, who cares? And I have this. Okay, 0, 0. Okay. Before minus half, it's down and concave up. It will be, you take -3, you have a negative value. You have a positive value. If you take more before -2, f of -3, it will be positive. So I know the graph will go like this until -2. Then it will be until minus half. It will be decreasing and concave up until minus half. So it's decreasing, concave up until minus half. Okay. Then it will be increasing and concave up. Increasing and concave up. then it will be increasing but concave down until 1. Then it will be increasing and concave down still, like this. So something like that. Okay, let me finish by this graph of the function, which is easy one, but you need to figure out one thing. This is x minus 1 over x minus 3 over x plus 1 times x plus 3. Okay, domain, all real numbers except minus 1 and minus 3. Intercepts x equals 0, y equal 1. So you have 0 and 1. Y equals 0, you have x equal 1, or x equals 3. Okay, correct. Vertical asymptotes, x equal minus 1, or x equal minus 3. Horizontal asymptote, y equal 1. Okay, f prime is this 8x squared minus 3 over x squared plus 4x plus 3 squared. And I will do just f double prime equal minus 16 x cubed minus 9x minus 12 over x squared plus 4x plus 3 cubed. I think you can do it easily. I have the asymptotes minus 1 and minus 3. These are the asymptotes. Minus 1, minus 3. I have this is 0, 1. That's it. I have x equal 1 and x equals 3. Okay. Yeah, it's, and this is asymptotes, y equal 1. Huh? Y equal 1 is an asymptote. Okay. So this one crossed. Equal 1. Y equal 1, yeah, at 0. Yeah, very clear. So you have what? X equals 0. Yeah, because this is cancelled. This is cancelled. So you have 8x equals 0 or x equals 0. Okay, so it will be crossed here. Okay. Then why is it? Between this, it will be concave up and increasing. So you have this. Here you have this. I think easy to check. Here we have what? This one goes there. Then it will reach this, go down, then it will reach this and go like this. Yeah, I think you can do it from f prime and f double. I will not waste time to do this. Let me finish by this, then I will remain with the multiple choice questions. Find the oblique asymptote, just calculation. Now the denominator is degree 2, huh? So divide this by this, you get what? Half x. Please note this is half x. Multiply, you have x cubed plus half x squared minus half x. Change minus plus So this is minus 3 over 2x squared plus 7 over 2x plus 10. Now we divide this by this, you get what? Minus 3 over 4. If you multiply it, you get minus 3 over 2x squared minus 3 over 4x plus 3 over 4. I don't care about this. This is cancelled, so I have 7 over 2 plus 3 over 4x. Who cares? Plus 10 minus 3 over 4. As I stop the slant asymptote or the oblique asymptote, the same thing. Y equal half x minus 3 over 4. Okay, I think I'll stop here. Now we graph many functions, so I think it will be all done enough. Let me stop the recording too. Thank you.